Hi guys, here is a question for us. Guys, I read the question. The question states find dy over dx of y equals to e raised to a half x from the first principles. So guys, here is our question. We want to find dy all over dx from the first principles. Guys, we identify first the formula for derivative of from first principles, and this is our formula, guys. This is the formula, guys, that we use, and as you can see is f prime x, that is first derivative of x, is equals to limit h tends to 0. As h tends to 0, f x plus h minus fx all over h. And so guys, we come and replace for our equation here. Instead of having that, we now have that. And now our function is e raised to a half x, and this is what now we have, guys. As you can see, the derivative of that function is equals to limit as h tends to 0, e raised to a half x plus h to bracket minus e raised to a half x. Guys, now we come and multiply this half to x and to h, and this is what we are having here. After we have that, guys, we can factor out e raised to a half x, because as you can see, we have e raised to a half x, and here we have e raised to a half x. When we do that, we shall be left with the e raised to a half h minus 1, and this is what we have, guys, as you can see. So guys, we keep this one aside, and now we deal with this one. Guys, we come now to the series. We usually have the series of e raised to x, and the series of e raised to x is as given below. The series of e raised to x is right here. So guys, we are going to use this series now to replace for e raised to a half h. And as you can see, guys, instead of now having x as our series have, we are now going to put a half h in the place of x, and that is what we are going to have here. So guys, we have now come and put in the equation right there. As you can see, we have put 1, because we have e raised to a half h, it will give us 1 plus a half h, which is represented by x here, plus the x is raised to 2, so a half h is raised to 2 also, all over 2 factorial, plus a half h is raised now to 3 all over 3 factorial, minus 1. As you can see, we have a minus 1 here. So this 1 and this 1 can cancel, but we have other figures here. So from there, guys, we can also divide the h you can see here. We can divide that h and this h. But remember, guys, if we are dividing, you have to divide every one of them. And so this is the first one. And then here, guys, you shall have a h less. When you divide by h, you have a h less. So this one is now going to be h raised to 1 for this. And for this, now we are going to have h raised to 2. And so on. So the next one will have h raised to 3 after we have cancelled one of the h's. But now, guys, after that, as long as we have h which sets to 0, all these are going to be 0 up to wherever they reach. All these are going to be 0. And so therefore we are going to have only a half that is going to be left. It's now going to be left. And so, guys, here I have not cancelled. Maybe now I can cancel here. Yes, this is 1. I cancel here. This is 2. And the other one will have 1. And finally, all this is going to be add up to 0. I also cancel that. That is where now cancellation comes. And then we are left with only a half. So this is what, guys, you are going to be left with. E raised to a half x, that is, limit as it h tends to 0, e raised to a half x multiplied by a half which has been left. And so therefore, guys, this is then our equation. That is dy all over dx is equals to a half e raised to a half x. And so, guys, that's our solution. Thank you for listening to me. Bye.